Today we're going to talk about equivalent fractions. So first, what is an equivalent fraction? It's fractions that represent the same value. So they're equal to each other. We're going to put them in simplest form, or what we call reduced form. A fraction is in simplest form when the greatest common factor of the numerator and the denominator is 1. So that means the only thing that fits into both the top and bottom is 1 when you have simplest form. So for example, for a simplest form, we could do 3/5. The only thing that fits into 3 and 5 is the number 1. So that would be simplest form.
So wouldn't that mean it would be 1/1?
Nope. The greatest common factor of the numerator. So a factor is a number that fits inside.
Also it'll be 1/5.
So 1/5 would work as a simplest form, but 3/5 here. 3, what's a common factor? What's the number that fits into 3 and fits into 5?
1.
1 is the only number. So we are in simplest form. Okay. Whereas if you have the number 2/4, what fits into 2 and 4? 1 does, right?
Yeah.
But what else fits in there?
2.
2 fits in there. So I could divide both of these by 2,
So 1.
and you would get 1/2. So the only thing that fits into 1 and 2 is 1. Okay? So that's reducing a fraction. Okay? Yes. Finding equivalent fractions. Okay? One way is to do this thing called shading, where you create some boxes that are the same size. And if we look at this first box, how many pieces are shaded in on the top box? 6 pieces shaded in. And how many total pieces? 8. So you would say that is 6/8. You could say that. Okay. What about the one underneath? There are how many pieces shaded in? 9 shaded in, and how many total? 12. What about the one on the bottom?
3, 4.
3 shaded in out of 4 total. If you look at each of those have the same amount shaded in. We just made the pieces different sizes. So 6/8 is the same as 9/12, which is the same as 3/4.
Oh, wow.
Okay, because we shaded in the same amount of the big rectangle is shaded in. We just cut them into different size pieces.
Oh.
Because I could take this bottom one and I could cut it right here. And now I would have 6/8 shaded in.
Yeah.
Okay. If I wanted to, I could cut it like the other one. And I would have 9/12 shaded in.
Oh.
Those are equal boxes.
Okay. So, I know my boxes that I drew aren't perfect. Imagine them being perfect lines though, okay? Another picture that is very common that you'll see on a lot of things is, that's not what I wanted,
Why did that just do
is people will draw circles and they'll make them like a pizza. And like if you have one whole pizza, right, and I cut that in half, and I take and I shade half of it, I have 1/2, right? If I take that same pizza, and now I'm going to cut it into 4 pieces, and I shade 2 of the pieces, I have 2/4, but it's the same amount of pizza as 1/2, right? So those are equivalent fractions, okay? So the bottom number is how many pieces you cut it into. The top number is how many pieces you have. Okay? So that's one way, is shading things. So whether you draw circles for pizzas or whether you draw rectangles for brownies, that's your choice. Okay? The other way is doing this thing, multiplying and dividing. Okay? So when I look at the top one here, 2/3 is equal to how many 18ths? What did you have to do to 3 to make it 18? How did you multiply 3?
6.
If you do times 6 to the bottom, we're going to do the same thing to the top. So I'm going to say same to top and bottom.
18. 12, 18.
So 3 times 6 is 18. So 2 times 6 would be 12. Okay, so you're multiplying the top and bottom by the same thing. So you can multiply to get equivalent fractions. So if I gave you a fraction and we said 1/4 is the same as something, we could multiply that by, what do you want to multiply it by?
2.
By 2. So if I did times 2 on the top, I do times 2 on the bottom. 1 times 2 is 2. 4 times 2 is 8. So 1/4 is the same thing as 2/8. You could pick any number as long as you do the top and bottom the same. So I could times it by 10 if I wanted, or 15, or 11. Okay? So if I did 1/4, we'll do it times 11 here.
That's 11.
So times 11. 1 times 11 is 11. 4 times 11 is 44. So 1/4 is the same thing as 11/44.
Well, you can put any number.
All right. So you can do lots of different numbers, okay, when you're finding equivalent. So that's the other way is dividing. So if I take 70, what would you divide 70 by to get to all the way down to 7?
10.
So if we divide by
10.
10 here
And divide by 10
and divide by 10 on the bottom, so 100 divided by 10 is
7/10.
just 10. So we have 7/10. Okay, so that's the other way. So if you have small numbers, it's always a good idea to multiply to get bigger ones. If you have big numbers, sometimes it's easier to divide. I tend to like to just multiply because I like to multiply by 2. That's pretty easy to do. I like to multiply by 10. It's pretty easy to do. Multiply by 5 isn't too bad. Okay, so if you have a big number like 70 over 100, you can still do times 2, right, with that. All right. So, but you can also divide. All right. So now this is what you guys have been asking about is writing fractions in simplest form. So this is the other thing that the assignment's going to ask about is, can you make this fraction in simplest form?
Yeah.
So a couple different ways. Use the greatest common factor. Personally, I don't really use either of these methods when I do it. I'm going to show you these two, and then I'll show you the method I use, and you can choose. Okay? So you have different options too. So the greatest common factor of 18 and 24, does anyone know that?
6.
Is 6. So if you know it, great. You would just divide by
6.
6 on the top and bottom. 18 divided by 6 is 3 and 4ths on the bottom. Okay? That's a pretty easy one. If you have really big numbers and you're not sure, right, that gets a little harder because we can't do greatest common factor in our head. Okay? So then I'm going to talk about this prime factorization. And this is, again, a way that works but isn't the best. In my opinion, I like to do it differently. So we're going to take 18 and we're going to make a factor tree. And we end up with 2 times 9. And we have 3 times 3. And then we're going to do 24. It's a factor tree. 2 and 12. 2 and 6. And 2 and 3. So some of you did it a little differently. You might have done 3s and 6s and things like that on there. So once you have all your prime numbers circled, the numbers for 18 are going to stay on the top. So 2 times 3 times 3 is on top of the fraction. On the bottom, you take your numbers for 24, which is 2 times 2 times 2 times 3. Okay. So number 1 is write the prime factors of the numerator and denominator. So here's the prime factors of the numerator are 2 times 3 times 3. Prime factors of the denominator, 2 times 2 times 2 times 3. Then it says cross off any prime factors that repeat. So if it's in the top and the bottom, we cross it off. So there's a 2 on the top. Is there a 2 on the bottom?
Yes.
Okay, so we're going to cross off 1, 2 on the top, 1, 2 on the bottom. There's a 3 on the top. Are there any 3s on the bottom?
No. Yes.
Yes, so cross off 1 3 on each. There's another 3 on the top. Is there another 3 on the bottom?
No.
No. So whatever's left, multiply it together. So on the top, we have just a 3 left. So we don't. It's just a 3 then, because we don't have anything to multiply by. On the bottom, you have 2 times 2.
4.
It's 4.
Oh, yeah, I got it right.
Okay?
That's
So that's second way. Okay? That sometimes helps with really big numbers. Now, can I show you the way that I really like to do?
Yeah. Sure.
I'm going to put it next to this greatest common factor one. I look at the number 18. So we're going to start with 18 over 24. And I see that 18 is an even number and that 24 is an even number. So to me, that means 2 fits into both. Would you agree? Both even numbers? So I'm going to divide by 2.
Yeah. But that's,
So I get 9 and 12.
you can still.
I can still go further because a number fits into 9 and 12, right?
Yeah.
What fits into 9 and 12? 3 fits into both. 9 divided by 3 is 3. 12 divided by 3 is 4.
Oh.
I call this the multi-step.
I don't like more common steps.
Typically when I do these, I just go multi-step. I don't do the prime factorization. I don't do the greatest common factor. I just keep thinking what numbers fit in. There are 3 different methods here. You are allowed to choose any one of those 3 to use or a combination of any of them. Sometimes you might know the greatest common factor and it works.
Yeah.
Okay? Sometimes you just say, hey, they're both even. Let's divide by 2. Oh, hey, 3 fits into both. Let's divide by 3. Sometimes you'll want to do the prime factorization. It's totally up to you.